Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the quantum numbers topic, students. This topic is from structure of atoms or atomic structure. This is the 11th class syllabus, students, or first PUC syllabus, second lesson. Okay, so this topic is very important for competitive exams as well as board exam students. So that's why I'm going to discuss about these quantum numbers. So quantum numbers, first of all, what is the importance of quantum numbers? Quantum numbers gives the complete information about the position of an electron in an atom. Okay, now see, students, quantum numbers. So what is the importance, students? They gives the complete information about the position of about the position of an electron in an atom. Okay, so quantum numbers gives the complete information about the position of an electron in an atom. Okay, Namma. So that means it is giving the address of the electron, students. That means in the atom where electron is present. That means in which shell electron is present, in that shell, in which subshell, in that subshell, in which orbital electron is present. That electron is positive spin or negative spin. That is the complete idea, Nana. So from these quantum numbers, we can understand the position of an electron in an atom. Okay, Namma. So that means, for example, X is a person, student. Suppose X is a person. Example, students, this one. X is a person. Okay. So I don't know this person is boy or girl. Okay. So X is a person, students. Now this person place is Vijayawada, students, where he is living. His place is Vijayawada. Okay, Vijayawada. And next one, in Vijayawada, in which area he is belongs? Now see, students, I'm giving the general example, Lana. Here X is a person, students. His place is Vijayawada. He is staying in Vijayawada, students. In Vijayawada, in which street? That means where his house, near to railway station, students. See here, near railway station. Okay, near railway station. Near railway station, his house number, door number is 10. Okay, his house door number, how much, Nana? 10. So in that house, that X person is boy or girl. Okay, na. So that person is that person is which one? That is boy or girl. So that means that is the address of the person, X person. I don't know that X person is a boy or a girl. Okay, so how to identify, students? First of all, that person belongs to which place? Vijayawada. And in Vijayawada, where he's staying, near railway station, students, his house number is 10. And his house number is 10, students. In that house number, that person is boy or girl. Okay, so that means this is giving the complete address of this person. Are you correct or not? So as it is here, this quantum numbers also giving the complete idea, that means complete information about the position of an electron. Are you understanding, students? So that means here a person. So in the place of here, in the I want here electron position. Okay, now so that's why here I am taking as electron. See here, I am taking here in the place of X person, I want position of an electron. Are you clear? Position of electron, I want position of an electron. Are you clear? Now this electron, where it is present, students, where first of all the electron position is shells. So electrons are present in the shells, students. Okay, and next one, near railway station, that is nothing but in shells. That electron is belongs to which shell? And in that shell, which subshell electron is present? This is subshells. Are you following? This is shell summa. This is subshells. In that subshells, which orbital electron is present? Are you clear? In that orbital, okay, na, in those orbitals, that electron, okay, in which orbital electron is present? After that, that electron, it is positive spin. Now, it is positive spin or negative spin. Are you understanding? So here I told you that person is boy or girl. Like that only, that electron is positive spin or negative spin. Positive spin is nothing but plus half. Negative spin is nothing but minus half, students. Are you clear? So this is the address of an electron, student. So first of all, electrons are present in the shells. In shells, in which subshell electron is present? Because shells contain subshells. Subshells contains orbitals. Orbitals contains electron, students. That means here the shells, so subshells, so orbitals, so electrons. So that means electrons mainly present in the orbital. Are you clear this one? So first of all, shells will be there. In the shell, subshells, subshells contains orbitals, orbitals contains electrons. Now see, students, these shells, about the shells, nana, here quantum numbers, 4 total quantum numbers, nana, divided into 4 types, nana. Total 4 quantum numbers are there. There are 4 quantum numbers. One is principal quantum number. So here first I am discussing 4 quantum numbers, students. See here, total 4 quantum numbers are there. 4 quantum numbers. So what are the 4 quantum numbers? First one is principal quantum number. Principal quantum number. Second one, students, azimuthal quantum number. Azimuthal quantum number. Okay. And third one is magnetic quantum number. Magnetic quantum number. And fourth one is spin quantum number. Are you clear? Spin quantum number. Understanding, students, total 4 quantum numbers are there. Principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Now see, students, these quantum numbers, first one is which one? Principal quantum number. Now this shell, here I told you this shells, subshells, orbitals, electrons. So here principal quantum number, shells indicates the principal quantum number, students. That means principal quantum number gives the information about the shells, students. So that means here total 4 quantum numbers I told you. These 4 quantum numbers, what they are discussing, see here. Principal quantum number, it is discussing about the shell, students. This is the principal quantum number. Principal quantum number, students. Are you clear? And these subshells, azimuthal quantum number gives information about the shell number, subshell number, sorry, azimuthal quantum number. This is magnetic quantum number, about the orbitals it is discussing. And electrons, this is nothing but spin quantum number. Are you clear? Understanding, students? So principal quantum number gives the information about shells. Azimuthal quantum number gives the information about subshells. Magnetic quantum number gives the information about orbitals. Spin quantum number gives the information about electron. Are you clear this one? So 4 quantum numbers giving the complete idea about the position of an electron, students, in an atom. Understanding? So X is a person, he is staying in Vijayawada. In Vijayawada, where he is staying near railway station, and his door number is 10, and that person is boy or girl. That is the secondary. Okay, now see, students, position of an atom. We have to find the position of an electron in an atom. So that means here the electrons are present in first shells. In shells, in shells, in which subshell electron is present? That is subshells. And next, in that subshells, orbitals will be there. In which orbital electron is present? In that orbital, the electron is positive spin or negative spin. Are you clear, students? This is shell, subshells, orbitals, electrons. So total 4 quantum numbers are there. So now I am going to discuss about these 4 quantum numbers, students. Now first one, principal quantum number. First quantum number is principal quantum number. What is principal quantum number? What is discussing? Principal quantum number, it is represented by small n students. How to represent? It is represented by small n. Are you understanding? It is represented by small n. And next one, this quantum number was introduced by, first point, this quantum number was introduced by Niels Bohr scientist. Niels Bohr. Okay, Nama. So, who introduced students this one? Niels Bohr. Clear this one, Niels Bohr. And after that, it explains about the number of the orbit, size of the orbit, energy of the orbit. That means it gives the complete information about the. It gives the complete information about the first one, name of the orbit, sorry, number of the orbit, number of the shell, number of the orbit or shell, both are same students, orbit or shell. So already I told you principal quantum number gives the information about the shell number. Are you clear? That is about the shell. And next one, and also it is discussing about the size of the orbit, size of the shell, size of the orbit. And third one, energy of the orbit, energy of the orbit, students. Clear this one? So it gives the information about these three students, number of the orbit, size of the orbit, energy of the orbit. Clear this one? So here, number of the orbit, if suppose we know that orbit, for example, this is an atom, these are the shells, students, these are the shells. Okay, these are the shells. Okay, so these are calling as shell or orbit, students. Are you clear? These are shells, Nana. That means the electrons here in the shells, who will be their electrons? The electrons revolving around the nucleus in a definite circular path is calling as shell. Are you clear? So this is the shell, students, or orbit, another name. So number of the orbit or shell, size of the orbit, energy of the orbit, students. So here these shells are represented by KLMN and numbered as 1, 2, 3, 4, students. Suppose I am taking one more shell, Nana. One more shell. This is K shell, this is L, this is M, this is N shell. Okay, these are numbered as 1, 2, 3, 4. Understanding, students? 1, 2, 3, 4. That is the number of the orbit. So the values of N are taken as, that means the shells are represented by K, L, M, N and so on. Okay, and numbered as 1, 2, 3, 4 and so on. Are you clear? 1, 2, 3, 4 and so on. And next, the second one is the size of the orbit. Size of the orbit is nothing but radius of the orbit, students. What is the radius of the orbit? So the radius of the orbit is equal to, this formula came from the Bohr's model, students, from the nth orbit. The radius of the nth orbit I am taking, this is equal to 0.53 into n square by z angstroms. Are you clear? So this formula came from the Bohr's model, Bohr's theory, students. Radius of nth orbit is equal to n square into h square by 4 pi square m e square z. So from this formula, students, here we got this answer. Understanding, h is the Planck's constant, this is the shell number, principal quantum number, and m is mass of an electron, E is the charge of the electron, Z is the atomic number. Okay, Nama. So these all the values, after substitution you will get these values, students. Clear this one? This is the radius of the nth orbit. Here some formulas. Energy of the orbit. What is the energy of the orbit? Third one, energy of the orbit is equal to minus 13.6 into n by n square into z square electron volt per atom. So this is the energy of the orbit, students. Are you clear? So here number of the orbit means the shells are numbered as 1 2 3 4 represented by KLMN, and the size of the orbit is nothing but radius of the orbit. It is value, this is the formula, students, important. And energy of the orbit, this is the formula. Clear this one? So this is about the principal quantum number, students. So it gives, so principal quantum numbers gives the complete information about the shell, students. Are you clear about the shells only? Clear? Shell number, shell size, and shell energy. Are you clear? Or orbit energy. So this is about the principal quantum number. And what is how to find number of electrons present in the orbit? Okay, so what is the formula, students? Important one. The number of electrons, the number of electrons present in the shell. Formula is 2n square. Formula is 2n square, students. Okay, now by using this formula, here see one table I will discuss you, students. Here one table, see Nana, orbit number. Orbit number, this is the first column. Second one, name of the orbit. Name of the orbit. Third column, number of electrons. Number of electrons. Now see, students, orbit number, name of the orbit, number of electrons. Now first one, orbit numbers. Orbit numbers are shell numbers. I am taking here 1 2 3 4 5 6 and so on. Okay, and here name of the orbit, students, K. Okay, K L M N O P and so on. Are you clear? Name of the orbit. Number of electrons, how many, students? What is the formula, students? Number of electrons present in the orbit, formula is 2n square. Now tell me, n is equal to orbit number 1. Orbit number means n. Are you clear? Orbit number or shell number, it is a principal quantum number. So n, nana, name of the orbit KLMN, right? N is equal to 1. How much, students? 2. Here how many electrons, nana? 2 electrons. Now n is equal to second shell. Second shell, so second shell means 2 into 2 square. How much, nana? 8 electrons. Now here n equal to 3 means 9 2s are 18. Oh. And here n is equal to how much? 4. Oh. 2 into 4 square. 16 2s are 32 electrons. And next one, 50 electrons, correct? 5 5s are 25, 25 2s are 50. 6 square means 36 2s are how much? 72 electrons and so on. Clear this one? So like this you have to find it, students. This is about the principal quantum number. Are you clear? So principal quantum number gives the complete information about the number of the orbit. Are you clear? So this is very important, students. This is complete information about the number of the orbit, size of the orbit, energy of the orbit. Are you clear? Next one, second one are, students, which one? Azimuthal quantum number. Now see, students, second one, azimuthal quantum number. Second principal quantum number, azimuthal quantum number. What is azimuthal quantum number? Now see, students, azimuthal quantum number. So azimuthal quantum number was given by, it was introduced by student Sommerfeld. Okay na? So first of all, azimuthal quantum number is represented by small l. How much? What nana? Azimuthal quantum number is represented by small l, and after that it was introduced by Sommerfeld. It was introduced by Sommerfeld. Are you clear? It was introduced by Sommerfeld students. Are you clear this one? Sommerfeld. And after that, what is azimuthal quantum number giving the information? That means it gives the information about the subshell, students. It gives the information about the subshells and the shapes of orbitals. Clear this one? So what is the second point, students? It gives the information about the, it gives the information about the subshells, about the subshells and the shapes of orbitals, and the shapes of orbitals. Clear, students? So it is giving the information about the which one, students? Subshells. So and shapes of orbitals, students. Shapes of orbitals. Clear this one? Subshells and shapes of orbitals. Now coming to the that means here azimuthal quantum number mainly depends on the principal quantum number values. Okay, it depends on the n values. Clear this one? N value is nothing but which one, students? It is the principal quantum number. That means it depends on the principal quantum number, students. Are you clear? N values. Understanding principal quantum number is represented by small n kada. So it is so that's why it depends on azimuthal quantum number. L values mainly depends on n values, students. Principal quantum number. Now see, students, if suppose n is equal to first shell I am taking, see here n is equal to, for example, now see here n is equal to 1 I am taking, n is equal to first shell. Okay, that means as this is principal quantum number, it is the first shell. So in the first shell, that means azimuthal quantum number values nana changes from, that means their range is 0 to n minus 1. So what is the range, students? 0 to n minus 1. L values range, how much nana? Range 0 to n minus 1. Very important, students. 0 to n minus 1. Now for example, I am taking n is equal to first shell. First shell means how many L values you will get? 1 minus 1, 0. That means only one value will get, that is 0. Are you following? See here. So n is equal to first shell, students. N is equal to first shell. So in the first shell, students, n is equal to, what is the range, students? L values range 0 to n minus 1, correct? If suppose n equal to 0, then 0 minus 1, here n equal to, sorry Nana, n equal to first shell, 1 minus 1, 0. That means here we will get value only one azimuthal quantum number value. So that is 0, students. It is equal to, for which subshell? S subshell. Are you following? So that means 0 means only one subshell, that is yes. Okay na? Yes, Nana. Now take here n is equal to second shell. N is equal to second shell means here n equal to 2, substitute 2 minus 1. 2 minus 1 is nothing but 1. 0 to 1. That means here we will get 0, 1 values. Are you following? So these are the, that means here 2 subshells we will get. 1, 2, 2 subshells. What are the 2 subshells, students? S and P. Are you clear? For S subshell 0, for P subshell L value is 1. Are you clear this one? Understanding, students? And S is known as here S subshell. Are you clear? This is S subshell, this is P subshell. Now n equal to third shell I am taking, suppose third shell. N equal to 3, substitute here. 3 minus 1. How much, students? 2. N equal to 3. 3 minus 1 means 2 you will get. Here what values you will get? 0 to 2 is nothing but 0, 1, 2. That means S, P, D. 3 subshells you will get. Are you clear? Third shell 3 subshells, second shell 2 subshells, first shell 1 subshell. Okay, now I am taking n is equal to fourth shell. N equal to 4, substitute 4 minus 1, 3. 0 to 3 means 0, 1, 2, 3. That means S, P, D, F. Are you clear? S, P, D, F. 4 subshells you will get. Understanding, students? So that means these subshells are mainly we calculated based on the n values. Are you correct or not? So that means azimuthal quantum number values mainly depends on the principal quantum number. Are you clear? So this is SPDF. Now here see, students, First shell contains only one subshell. Second shell contains two subshells. Third shell contains three subshells. 1, 2, 3. Fourth shell contains how many subshells? These are all are which one, students? Subshells. Are you clear? So these are subshells, Nana. Okay. Yes, subshell SP, SPD, SPDF. Are you clear? Subshells are represented as SPDF. Okay. So these are the subshells. Are you clear? SPDF. Now see, students, the number of electrons in the given subshell. What is the formula? The number of electrons in a given shell. In a given shell, formula is 2 into 2L plus 1. In a this is subshell, Lama. In a given subshell, sorry students, in a given shell, what is the formula? 2n square kada. In the given subshell, what is the formula? 2 into 2L plus 1. Are you clear this one? 2 into 2L plus 1, students. Okay. Now see, students, here one table I want to discuss you. Shell, subshell, number of electrons in shell, number of electrons in subshells I am going to discuss. See here, first column is shell. Shell, subshell, number of electrons in filled shell, in shells. Okay. Next one, number of electrons in subshells. Okay, in subshells. This is in shells, so these are in subshell, students. Now see here, in now see, in shell. In shells, Nana, shells, how to represent, students? KLMN kada. How to represent shells? KLMN. Now I am taking the 4 shells, students. That means here n value how much? First shell, n equal to 2, n equal to 3, n equal to 4. Correct? So n equal to 4 subshells. Are you clear? That means n is equal to first shell, second shell, third shell, fourth shell. KLMN. What are the subshells, students? n is equal to 1. First shell kada. How many subshells will be there in the first shell? Here I told you already, only one subshell. Second shell, 2 subshells. Third shell, 3 subshells. Fourth shell, 4 subshells. Okay, so n is equal to 1. What is the how many subshell? 1 subshell, that is yes. See here, what is the subshell? Yes. Take here yes. Next one, SP. Second shell kada. So what are the subshells, students? S comma P. Third shell, SPD. Fourth shell, SPDF. Are you clear? 4 subshells will be there. Okay, like this I am writing. What about L value, students? Azimuthal quantum number value for S, 0. For S subshell, 0. P subshell, 1. S0, P1, D2. S0, P1, D2, F3. These are all which values, students? These are all L values, correct? So L values range is 0 to n minus 1, correct? So that's why these are which values? So L values. Are you understanding? So here these are L values. Understanding? So that means for S subshell, what are the L values, students? L values for S subshell 0, P subshell 1, D subshell 2, F subshell 3. Just you remember this step, this one, students. Okay, now you can answer any question, students. Just you remember this one. Are you clear? S subshell 0, S0, P1, S0, P1, D2, F3. Are you clear? So this is the L values. Okay, so like that only here also I am taking Nana. See here L equal to 0. Now here SP is there. SP means S value how much? L, 0, P value 1. Here S for L values how much? S0, P1, D2. Here L value 0, 1, 2, 3. Correct? Now coming to the number of electrons present in the shell, formula 2n square. Number of electrons present in the subshell, 2 into 2L plus 1. Are you clear? This is the formula. 2 into 2L plus 1. Understanding? Now 2n square formula is there. So n is equal to 1, substitute. N equal to 1 means 2 into 1 square, 2 electrons. So here SP, n equal to 2, second shell. That means 2 4s are 8 electrons you will get. Here how much? N equal to 3. 3 square means 9. 9 2s are 18 electrons. N is equal to, this is nth shell. So n is equal to how much? 4. So n equal to 4 means 4 square. 4 square means 16. 16 twos are 32 electrons. Are you clear? This is number of electrons in the shell. Number of electrons present in the subshell. How much, students? 2 into 12 plus 1. That means L value 0. So substitute here. 2 into 0 plus 1. 1. 2 ones are 2 electrons. Are you clear? 2 ones are 2. Now coming to the next one, say students, for p subshell, suppose here s equal to 0 means 2 you will get. Next L value 1 substitute, then here 1 means 2 plus 1 3, 3 twos are 6. That means here how many electrons you will get? 2 comma 6. Are you clear? For s, because 2 are there, s value, for s L value 0 na, 0, when you substituted L value 0 you will get 2. If you substitute L is equal to 1, p value will get. Are you clear? In p subshell how many electrons are there? And here in the third shell 0 1 2, and 0 if you substitute how much you will get? 2. L value 1 if you take, you will get p subshell how many electrons? 6 electrons. In the d subshell how many electrons? 2 substitute here, 5 twos are 10 electrons. Are you clear? 10 electrons. Now coming to here 2 6 so 10, n equal to 3 substitute, 2 3s are 6 plus 1 7, 7 twos are 14 electrons. Are you clear? 14 electrons. So these are all the L values for S subshell. In S subshell how many electrons? 2. P subshell 6. D subshell 10. No. F subshell. This is which one? This is S subshell. Okay, this is S subshell. This is SP. This is SPD. This is SPDF. Are you clear? That means in S subshell how many electrons, students? In S subshell 2 electrons. P subshell 6 electrons. D subshell 10 electrons. F subshell 14 electrons are present. Are you clear? So this table is, you have to remember, students, important. Are you clear? So that means azimuthal quantum number gives the complete information about the subshell, students. So this is about the subshells. Nana. Now next one is, for third one is which one, students? Magnetic quantum number. So what is the third one? Third one, magnetic quantum number. See students, third one, magnetic quantum number. Now see Nana, magnetic quantum number. It was introduced by Landé. First of all, it is represented by small m, students. How to represent small m? And it was introduced by Landé. It was introduced by Landé. Okay, so Landé. And next it gives the information about the which one, students? Orbitals. It gives the information about the orbitals, students. Okay, about the orbitals. Understanding? So the total number of values of m. Okay, so first one, total number of values of m is equal to formula 2l plus 1. Understanding, students? And L values, Nana, range is here, see. So this m values, Nana, 2l plus 1. The total number of values of m is equal to 2l plus 1. 2l plus 1. And next thing, this azimuthal magnetic quantum number m values, Nana, m values mainly depends on which values? L values. Are you clear? So because already I told you, azimuthal quantum number values are depends on principal quantum number. And next, magnetic quantum number values depends on azimuthal quantum number values. Are you understanding? So that's why here, understanding? So it's range, Nana, and it can be, if you take the range, L values range, L values range, Nana, minus L and so on, 0 and so on, plus L. Are you understanding? So L values, sorry, M values. So M values range is how much, students? M values are depends on L values. So minus L to plus L, students. Minus L to plus L. Clear? So number of the, so first of all I'm going to discuss one table, students. Here, name of the subshell. So now coming to the four columns I'm taking here. See, name of the subshell, L values, M values, number of orbitals, okay, number of orbitals, students. Next one, name of the, name of orbitals, number of orbitals over, and name of orbitals, name of orbitals. Total 5 columns I am taking, Nana. In this 5 columns, see here. So first one is name of the subshell. I am taking here S subshell, B subshell, D subshell, P, D. Okay, 3 subshells I am taking, students. Are you clear this one? SPD subshells I am taking. And here what about the L values, students? L values, Nana, for S subshell 0. L values we know that already I told you. Here L values how much? S subshell 0, P1, D subshell 2, F subshell 3. L values. What about here M values? M values now we are going to discuss. Okay, now see, students, here SPDF, L values what, students? For S subshell 0, for S subshell 0, for P subshell how much? 1, D subshell 2. M values, so here M values, how to find it? Because M values are depends on L values, so that's why here L value we know that 0, just you substitute here. 2 into 0 means how much, Nana? 0 plus 1. Are you clear? Here S value 0, S value sorry, L value 0, so here substitute L value 0, that means you will get 1. That means magnetic quantum number value is 1 value, that is 1, how much, which one, student? 0. So that is 1 is equal to how much, Nana? 0. So this is only one value. And coming to P, Nana, P is L value how much? 1. L equal to 1, substitute here. 2 ones are 1, 2 ones are 2 plus 1, how much, Nana? 3. So that means 3 values you will get. Magnetic quantum number values, 3 values you will get. Are you understanding, Nana? Yes, here L value for S subshell, L value 0, substitute 1 value will get magnetic quantum number, that is 0. And if I take L equal to 1, L equal to 1, how much, Nana? 2 plus 1 equal to 3, that means 3 values you will get. What are the 3 values, students? L equal to, what are the 3 values? So minus 1, 0, plus 1. Are you clear? 3 values you will get. Understanding, students? 3 values. So what are the 3 values, Nana? Minus 1, this is L equal to here you have to take. So what are the 3 values? Minus 1, 0, and plus 1. Here in the place of L, 1 you can take. Okay, na? L you can take 3 values. That means what you will get? Minus 1, 0, plus 1 you will get. 3 values you will get. If suppose L equal to 2 you take, then 2 2s are 4, 4 plus 1 how much, Nana? 5 values you will get. So 5 values. L equal to 2 kada, so that means minus 2 2 plus 2. Minus 2 2 plus 2 is nothing but minus 2 minus 1 0 plus 1 plus 2. Are you clear? So what values you will get? Minus 2 minus 1 0 plus 1 plus 2. Are you clear, students? Plus 1 plus 2. Okay, so these are the values of M. Number of orbitals. So in S subshell, how many orbitals will be there, students? Only one orbital will get. For in P subshell, how many orbitals? So how many orbitals? That means in S subshell, how many orbitals? One orbital. P subshell, how many orbitals? This is completely P subshell. This is completely D subshell. Okay, now P subshell, how many orbitals, students? How many orbitals you will get? 3 subshells, because how many M values? 3 kada, so that's why you will get number of orbitals 3. Are you clear? So that means 3 orbitals you will get. In P subshell, how many orbitals? 3 will get. In D subshell, total how many M values? 1, 2, 3, 4, 5. That means based on the M values, here M is indicates, M is giving the information about the orbitals. That means here M values we got 5 values, so that's why here we will get 5 orbitals. Understanding, students? 1, 2, 3, 4, 5. So total 5 orbitals you will get. Understanding? So these are the orbitals, students. Name of the orbitals. Name of the orbitals means this is s orbital. This is s orbital. This, what are the orbitals, students? Px, py, pz orbitals. Px, py, pz. This is px, py, pz. 3 orbitals. 1, 2, 3, 4, 5 orbitals. What are the 3 orbitals, students? Here you see the na. Here this value is how much? This value 3 orbitals. This minus 1, 0, plus 1. Suppose I am taking this is minus 1, this is 0, this is plus 1. Then here which one we have to take? Px, this is pz, this is py. Are you clear? So these 3 orbitals are px, py, pz. Now if minus 2, minus 1, 0, plus 1, plus 2. This is minus 2. Suppose I am taking minus 2, minus 1, 0, plus 1, plus 2 I am taking. This is dxy, this is dyz, this is dz square, and this is dxz, and this is dx square minus y square. Are you clear? Dx square minus y square, students. Total 5 orbitals are there. Are you understanding? So this is about the name of the orbital, students. Clear this one? The total 5 orbitals are there. Name of the orbitals. Understanding, students? Here pz value 0. Here dz square value 0. Okay, 0. This dxy dyz value is negative. Dxz value plus 1. Dx square minus y square value how much? M value plus 2. These are all which values? M values. Are you clear, students? M values. So this is about the magnetic quantum number, students. Okay, Nama. Now I am going to discuss about the spin quantum number. Now see, students, spin quantum number, first, fourth one. So spin quantum number. Spin quantum number. So what about spin quantum number, students? First of all, this quantum number is represented by small s, nana, small s, and after that it was introduced by Uhlenbeck and Gaudsmith. Who given, students? First point, it was introduced by Uhlenbeck and Gaudsmith. Okay, Uhlenbeck and Gaudsmith, students. Okay, understanding? So Uhlenbeck and Gaudsmith. So this was introduced, students, and after that it has 2 values. S has 2 values, students. One is plus half, another one is minus half. Plus half is nothing but clockwise direction. This is anti-clockwise. Are you clear? Anti-clockwise direction. Understanding, students? So this is plus half or minus half. That means it gives the information about the spin of an electron. It gives the information about the spin of an electron, students. So that electron is plus half or minus half. So this is about the spin quantum number, students. Are you clear? Spin of an electron. Clear this one, students? So this is about the spin quantum number. So finally, magnetic total quantum numbers for principal quantum number, azimuthal quantum number, magnetic quantum numbers, and azimuthal last one is spin quantum number. Are you clear, students? Spin quantum numbers. Understanding? So principal quantum number, mainly principal quantum number, it is giving the information about n. That means shell number. Are you clear? Shell number. That means K, L, M, N, like that. Okay. Next one, azimuthal quantum number. So finally I am giving the conclusion, students. Azimuthal quantum number gives the information about subshells. Okay, na? So S, P, D, F. Are you clear? So these are n values. These are L. For L subshell, L values what, students? S subshell 0. Next P subshell 1, D subshell 2, F subshell 4. L values. Are you clear? L values 4. Next, Nana, magnetic quantum number. It gives the information about orbitals. Okay, na, orbitals. That means in S subshell, how many orbitals? 1 orbital. P subshell, how many orbitals? 3 orbitals. D subshell, how many orbitals? 5 orbitals. 1, 2, 3, 4, 5. Okay, and F subshell 7 orbitals will be there. Are you clear? Total 7 orbitals. 1, 2, 3, 4, 5, 6, 7. Total 7 orbitals will be there. So it is giving the information about the orbital students. Okay, now. And spin quantum number, it gives the information about electron. Electron spin. Electron spin, nana, that is plus half or minus half. Clear? So plus half or minus half students. Clear this one. So this, based on this topic students, in the next video I will discuss the problem students, previous year's questions, how to solve that questions. Okay, now then you can easily understand this principal quantum numbers. Understanding, nana. See students, what we discussed in the quantum numbers. See here. So quantum numbers, structure of atom, 11th class. So this one, it gives the complete information about the position of an electron students. An electron in atom. Suppose X is a person, he is staying in Vijayawada near railway station, door number 10. He is a boy or girl, that is secondary. And position of an electron. That means electrons are present in the shells. In shells, in which subshell electron is present, in the subshell in which orbital is present, in which orbital electron is present. Are you clear? And later that electron is positive or negative spin. So that means principal quantum number gives information about shell number, azimuthal quantum number gives information about subshell, magnetic quantum number gives information about orbital, spin quantum number giving the information about spin of an electron. Are you clear students? So this is about the quantum number students. I hope you like this video students. If you like this video, please like, share, comment and subscribe my channel, Nana. Please give like. Okay now. So please support me students, then I can do still more videos. Please try to understand. Thank you very much students.